standard UL 500 AC does not mandate short circuit current ratings (SCCR) for power conversion equipment. However, if a manufacturer opts to provide a short circuit current rating for a power conversion equipment product, they must adhere to the testing procedures outlined in UL 60947.1, which serves as the harmonized version of International Electrotechnical Commission IC 60947.1, specifically tailored for industrial automation and control equipment. Within UL 60947.1, the short circuit current rating is established through testing the product under a prospective short circuit current. This prospective short circuit current represents the maximum current level the product is likely to encounter during a fault. This test involves connecting a fuse or circuit breaker in series with the product. This short circuit current rating is then defined as the highest prospective short circuit current value that the fuse or circuit breaker can safely interrupt without causing any damage to the product itself. The specific type of fuse employed in this test is contingent upon the unique characteristics and design of the product under evaluation. However, in general, a fuse characterized by a high interrupting rating will be necessary to achieve a correspondingly high short circuit current rating. The interrupting rating represents the maximum current that the fuse can safely interrupt without sustaining damage to itself or compromising the integrity of the equipment it is intended to protect. As an example, if a drive possesses a short circuit current rating of 42 kA, this indicates that the drive has undergone testing using a prospective short circuit current of 42 kA. This also suggests that the fuse or circuit breaker utilized during the test successfully interrupted this current without inducing any damage to the drive. It is crucial to recognize that the short circuit current rating of a product is valid only under the specific conditions that prevailed during the test. These conditions encompass the type of fuse or circuit breaker used, the voltage and frequency of the power supply, and the ambient temperature. Any alteration to these conditions may result in a modification of the product's short circuit current rating. To elaborate further on the significance of short circuit current ratings and the testing methodologies involved, it is essential to delve into the underlying principles and practical implications. Short circuit current ratings are critical for ensuring the safety and reliability of electrical equipment and systems. They provide a measure of the equipment's ability to withstand and safely interrupt high-magnitude fault currents that can occur during short-circuit events. Without adequate short-circuit current ratings, equipment can be damaged or destroyed, leading to potential hazards such as fires, explosions, and electrical shocks. The UL 60947.1 standard outlines comprehensive testing procedures to determine the short-circuit current ratings of industrial automation and control equipment. These procedures involve subjecting the equipment to simulated short-circuit conditions using calibrated test circuits and protective devices such as fuses and circuit breakers. The test circuit is designed to deliver a controlled prospective short-circuit current to the equipment under test. This current represents the maximum fault current that the equipment is likely to experience in a real-world application. The protective device, typically a fuse or circuit breaker, is connected in series with the equipment to interrupt the fault current and protect the equipment from damage. During the test, the prospective short-circuit current is gradually increased until the protective device operates and clears the fault. The short-circuit current rating is then determined based on the maximum prospective short-circuit current that the protective device can safely interrupt without causing damage to the equipment or the protective device itself. The selection of the appropriate fuse or circuit breaker for the short-circuit current testing is critical to ensure accurate and reliable results. The protective device must have an interrupting rating that is equal to or greater than the prospective short-circuit current. The interrupting rating is the maximum current that the protective device can safely interrupt without failing or causing damage to itself. In addition to the interrupting rating, other factors such as the voltage rating, current rating, and time current characteristics of the protective device must also be considered to ensure proper coordination with the equipment under test. The voltage rating of the protective device must be equal to or greater than the system voltage. The current rating of the protective device should be selected based on the normal operating current of the equipment and the expected overload conditions. The time current characteristics of the protective device should be coordinated with the equipment's thermal withstand capability to prevent nuisance tripping and ensure adequate protection against overloads and short circuits. The ambient temperature during the short circuit current testing is also an important factor that can affect the results. The temperature can influence the performance of the equipment and the protective device. High temperatures can reduce the interrupting rating of fuses and circuit breakers and increase the thermal stress on the equipment. Therefore, the testing should be conducted at a specified ambient temperature or with temperature compensation to ensure accurate and reliable results. Furthermore, the UL 60947.1 standard specifies detailed requirements for the test equipment, instrumentation, and procedures used for short-circuit current testing. The test equipment must be calibrated and maintained to ensure accurate and repeatable results. The instrumentation must be capable of measuring the prospective short-circuit current, voltage, and time accurately. The test procedures must be followed carefully to ensure consistent and reliable results. It is also essential to understand the limitations of short-circuit current ratings. The short-circuit current rating of a product is only valid for the specific conditions under which the test was conducted. These conditions include the type of fuse or circuit breaker used, the voltage and frequency of the power supply, and the ambient temperature. If any of these conditions change, the short-circuit current rating of the product may also change. Therefore, it is crucial to verify that the actual installation conditions are within the range of the test conditions to ensure that the short-circuit current rating is valid. In summary, short-circuit current ratings are essential for ensuring the safety and reliability of electrical equipment and systems. The UL 60947.1 standard provides comprehensive testing procedures to determine the short-circuit current ratings of industrial automation and control equipment. The testing involves subjecting the equipment to simulated short-circuit conditions using calibrated test circuits and protective devices such as fuses and circuit breakers. The selection of the appropriate fuse or circuit breaker, the ambient temperature, and the test equipment and procedures are all critical factors that can affect the results. It is also essential to understand the limitations of short-circuit current ratings and verify that the actual installation conditions are within the range of the test conditions. Let's consider a practical example to further illustrate the importance of short-circuit current ratings. Imagine a manufacturing facility that uses a large number of electric motors to power its production equipment. These motors are connected to a power distribution system that is capable of delivering a high prospective short-circuit current. If a short circuit occurs in one of the motors, a large fault current will flow through the motor and the power distribution system. If the motor and the power distribution system do not have adequate short-circuit current ratings, the fault current can cause significant damage to the equipment. The motor windings can overheat and melt, the circuit breakers can fail to trip, and the power distribution system can be damaged or destroyed. This can result in costly downtime, equipment replacement, and potential safety hazards for the workers in the facility. However, if the motor and the power distribution system have adequate short-circuit current ratings, the fault current can be safely interrupted by protective devices such as fuses or circuit breakers. The protective devices will trip quickly and isolate the fault, preventing further damage to the equipment and ensuring the safety of the workers. Therefore, it is crucial to select electrical equipment and systems with appropriate short-circuit current ratings to ensure the safety and reliability of the manufacturing facility. In addition to the UL 60947.1 standard, other standards and regulations also address short-circuit current ratings. For example, the National Electrical Code, NEC, specifies requirements for the short-circuit current rating of electrical equipment and systems in buildings and other structures. The NEC requires that electrical equipment be marked with its short-circuit current rating and that the available short-circuit current at the equipment be determined. The NEC also provides guidance on selecting and installing protective devices to protect electrical equipment from short-circuit currents. Furthermore, various industry organizations and testing laboratories also provide resources and guidance on short-circuit current ratings. These resources can help engineers and technicians understand the requirements for short-circuit current ratings and select appropriate equipment and protective devices. In conclusion, short-circuit current ratings are a critical aspect of electrical safety and reliability. The UL 60947.1 standard provides comprehensive testing procedures to determine the short-circuit current ratings of industrial automation and control equipment. The selection of the appropriate fuse or circuit breaker, the ambient temperature, and the test equipment and procedures are all critical factors that can affect the results. It is also essential to understand the limitations of short-circuit current ratings and verify that the actual installation conditions are within the range of the test conditions. By understanding and applying the principles of short-circuit current ratings, engineers and technicians can ensure the safety and reliability of electrical equipment and systems in various applications. In practical terms, determining the appropriate short-circuit current rating for a specific application involves several steps. Firstly, it is necessary to determine the available short-circuit current at the point of installation. This can be calculated using engineering software or obtained from the local utility company. Secondly, the short-circuit current ratings of all electrical equipment and components in the system must be determined. This information is typically provided by the equipment manufacturers. Thirdly, the short-circuit current ratings of the equipment must be coordinated with the available short-circuit current at the point of installation. This ensures that the equipment can safely withstand and interrupt the maximum fault current that it is likely to experience. Fourthly, appropriate protective devices such as fuses and circuit breakers must be selected and installed to protect the equipment from short-circuit currents. The protective devices must have interrupting ratings that are equal to or greater than the available short-circuit current at their point of installation. Fifthly, the electrical system must be properly grounded to provide a low impedance path for fault currents to return to the source. This helps to minimize the voltage rise during a fault and reduce the risk of electrical shock. Finally, the electrical system should be regularly inspected and tested to ensure that it is operating properly and that all protective devices are functioning as intended. This helps to identify and correct any potential problems before they can lead to a short-circuit event. In addition to the technical aspects of short-circuit current ratings, it is also important to consider the economic implications. Selecting equipment with higher short-circuit current ratings can increase the initial cost of the equipment, but it can also reduce the risk of damage and downtime in the event of a short circuit. Therefore, it is necessary to balance the cost of higher-rated equipment with the potential cost of downtime and repairs. Furthermore, it is important to consider the long-term maintenance and replacement costs of electrical equipment. Equipment with lower short-circuit current ratings may be more susceptible to damage and may need to be replaced more frequently. This can increase the overall cost of ownership over the life of the equipment. Therefore, it is important to consider the total cost of ownership when selecting electrical equipment and components. In summary, determining the appropriate short-circuit current rating for a specific application involves a comprehensive analysis of the available short-circuit current, the short-circuit current ratings of the equipment, the coordination of protective devices, the grounding of the electrical system, and the economic implications of equipment selection. By carefully considering all of these factors, engineers and technicians can ensure the safety, reliability, and economic viability of electrical systems in various applications. In conclusion, the world of short-circuit current ratings and the standards that govern them, such as UL 508C and UL 60947.1, is a complex yet crucial aspect of electrical engineering. Understanding these concepts is paramount for ensuring the safety and reliability of electrical equipment and systems. From selecting the appropriate fuses and circuit breakers to coordinating protective devices and grounding systems, every step in the process plays a vital role in preventing catastrophic failures and protecting personnel from harm.